Let's talk some more about limits of quotients. Previously, we said that if the limit of the numerator was equal to L and the limit of the denominator was equal to M, and if M is not 0, then the limit of the quotient is L over M. And that was part 1 of the limit law for division. But what happens if the limit of the denominator is equal to 0? The answer is it's going to depend on what the numerator is doing. If the limit of the numerator is something other than 0, then if you look at f of x over g of x, then when x is approaching a, we're going to get numerators that aren't near 0. So they're not small. But our denominators are going to be really close to 0. So we're going to be dividing a number that's not small by one that is really small. And the result is going to be huge. And as the denominator gets smaller and smaller, this quotient is going to get even huger. For instance, if we take 5 over 0.01, we get 500. But if we have 5 over 0.001, we get 5,000. Now, we don't know the signs of these things, so it could be huge positive or huge negative. And if the denominator equals 0 exactly, then this quotient might not be defined at all. But one thing is for certain. As x approaches a, there's no way that this quotient can be approaching any fixed number. So the limit does not exist. So that's part 2 of the division limit law. But that still leaves a third case. If the limit of the denominator equals 0 and the limit of the numerator also equals 0, then what? You might be tempted to say that this limit won't exist either, but that's not necessarily so. A lot of interesting things can happen. For instance, let's say that we want the limit as x approaches 0 of 2x over x. And here the numerator is continuous, so as x approaches 0, we can just plug in, and we see that the numerator is approaching 0, and same thing with the denominator. But we don't want to say that this limit is 0 over 0. 0 over 0 isn't defined, but this quotient, we know it's 2. Well, almost everywhere it's 2. It's not equal to 2 when x is 0, but when we're taking the limit as x approaches 0, what happens at x equals 0 doesn't matter. So this quotient is 2 everywhere that counts, and so its limit is 2. Okay, you might be complaining that this seems like an exception, sort of a special case. But really, this situation of a quotient where both the top and the bottom go to 0, and yet the limit of the quotient still exists, that happens a lot in calculus, and it's incredibly important. So we have some questions for you so that you can dig in and really understand how this comes about. Talk to you later.